Last week we covered chapter 7, which was 2 sections. And then this week we'll cover 8.2 and 9.2. Excuse me. I will talk a little bit about 8.1 and 9.1 because you kind of need some of it for 9.2 and 8.2. Sorry. But then next week will be your exam. So your exam's over the 2 sections in chapter 7 and then 8.2 and 9.2. So it will be Friday, April 1st. The take-home portion will be due Sunday, so the 3rd. And the in-class portion will be on the 1st at 2 o'clock. Any questions on that? It'll be set up just like the last one. That's it. Is there any questions on anything? Okay, 8.2 starts out with some definitions of critical number and relative max and min. And I talked a little bit about it when we were finding the derivatives before. So in section 8.2, the first definition is what a critical number is. A critical number is the numbers in the domain of f of x where the derivative equals 0 or does not exist. On the interval. If there was a domain given, like just A and B, then you only take the critical values in that interval. On ones where it's just all real numbers, then it would be all of them. A relative max or min occurs at the critical numbers and the endpoints. So the critical numbers are relative highs and lows on the graph, but so are the endpoints. So if we had a graph these two would be, the x values would be critical numbers. And this one, because it's a high spot, it would be a relative max. And this is a low spot, like a valley, it would be a relative min. But the endpoints can also be high and low points. For instance, if this is going up, then this is the highest point in this area. maybe not the highest one in the graph, maybe this went up even higher, but it's still a relative max. Where this one, at this point, the y value, it's the lowest y value in this area. And so it's a relative min. So your endpoints, if there are endpoints, can be relative max and mins, along with the critical numbers. So if we look at number 1, they want us to find all the relative extrema. And that just means any relative max or min. Now, these two ends keep going, so there's no endpoints, but there is a low point. Notice the increasing and decreasing change here. It was decreasing and then it starts increasing. And that's what 8.1 does. It does where the graph's increasing and decreasing. But here it's decreasing and then it starts increasing. So right here at this value, we would have had a critical value. And it looks to be at 1.5. And the low value is at 1, 2, 3, -4. So there's a relative min of, and then you put the y value, which was -4, at x equals 1.5. This one, notice that the vertex of the parabola is a high point on the graph. So that there's a relative max of, and the y value, which is 1, at x equals 4. So any high and low. These two graphs didn't have endpoints because they have arrows, they keep going. Most of them in this one part do. Let's look at some with more than one. Okay, number 5. Notice there the increasing and decreasing change at 2 different spots. It's increasing to here, then it's decreasing, and then it's increasing. So there is 2 critical values. Looking at the leftmost, this one here, would, where x is -4, would that be a max or a min? Anyone? Yes, it's a max. It's a high point on the graph in relationship to the parts around it. It's not the highest because notice this keeps going, but it is a relative max. So there's a relative max of, and then you put the y value, 1, 2, 3, I think it's 3. Relative max of 3 at x equals -4. Any questions on that part? Okay. Go ahead and write the second one. The one at -2. So this one would have a relative min of, and the y value is 1, at the x value, which is -2. We're going to do number 8 next, but is there any questions on number 5? Okay, go ahead and try number 8. How many critical numbers are there in the graph for number 8? Anyone? 3, yes. Because that's like, if you look, it's decreasing and then it's increasing. So this is one of them. Then it increases and decreases, so it's here. Then it decreases and increases, so it's here. So there's 3 critical numbers. Now notice that the 2 relative mins are both at the same y value. When that happens, you can write them as 1. So we know there's a relative min of 0, because this would be our y value 0, at -3 and 3. So when a relative min or a max, if there's more than one at the same y value, you can write them together. This one here would be a max of 1, 2, 4 at x equals 0. Any questions on that? So your max or your min is your y value, and then you state where you found it at, and that's the x value. Critical numbers are x values. So number 8, the critical values were -3, 3, and 0. Any questions? Okay. Number 13. Find the x value of all points where the function defined as follows has any relative extrema. Find the values of the relative extrema. So the first part, finding where there are relative extrema, that's critical numbers, that's your x. Finding the values of the extrema is your y. And relative extrema, that just means max and min. So we'll try number 13. So we have x squared minus 10x plus 33. Well, we know this is quadratic because the degree is 2, which means it's a parabola. And the a is positive, which means this parabola is going up. So there should be one critical number. Your critical numbers will be, if you take the degree and minus 1, that's how many critical numbers you should have when it's a polynomial. Now, sometimes there's double roots, so if it was a 4, there might be 2 instead of 4 or 3 of them, because one could be a double root. But rule of thumb, whatever your degree is minus 1, there should be that many critical numbers. So to find the critical number, take the derivative and set it equal to 0. So we take the derivative, we get 2x minus 10, and we set that equal to 0. Add the 10 over, divide by 2. 5 is our critical number. So when x is 5, we will have, looking at this graph, a minimum. Now there's 2 ways of finding this value. One way, plug it back into in this case it's the original, but sometimes maybe we're given revenue and cost and we find profit, and then we take the derivative of the profit. So rule of thumb is look where your derivative is and use the one before it. In most of these right now, we're going to use the original, but that will change later. So look where the derivative is and use the one before. So if we find f of 5, (25 minus 50 plus 33, we get 8. Is everyone getting 8? For some reason, I thought I got a different value when I did it earlier. Okay, now we're going to look at it using the graph. Okay, if we go to Desmos, and we're going to graph the one before the derivative, in this case, the original. Y equals x squared minus 10x plus 33. Notice the graph. Notice the point. So another way of finding it is using the graph. It's wherever you're increasing and decreasing is changing. On the in-class portion, of course, you'll have to be able to do it by hand, because you will not have access to Desmos. But there would be a relative min of 8 at x equals 5. Any questions on that? Let's try number 17. Any questions so far? So go ahead and take the derivative. So the first thing you want to do is take your derivative and set it equal to 0 to get the critical numbers. 3 times negative 4/3 is a negative 4x squared. 2 times negative 21 over 2 is a negative 21x. And then the 1 is a negative 5. I thought it came out nice. Oh no, okay. No, this is factorable. Would you try factoring it, or would you use the quadratic formula? Does anyone have a preference? Factor, okay. We're setting it equal to 0, so we can factor. I probably would, because they're all negative, I would divide by a -1 first to get rid of so many signs. And then we want, because there's a number in front, 4 times 5 is 20. We want to multiply to get 20 and add to get the middle term, which is a positive 21. 20 times 1. When we multiply, we get 20, and when we add, we get 21. So remember, because there's a number in front, we divide by it. And if possible, reduce. This will reduce by 4, so we'll have 5 over 1. Put the x in the bottom, x plus 5. This one will not reduce, so 4x plus 1. Now, if you can do trial and error, that is fine. Use trial and error. But if you can't, this is a simple, quick way. When you have two things multiplied together that give you 0, that means one of them needs to be 0. So you can set them each equal to 0 and solve. Subtracting the 5, we get a -5. Subtracting the 1, and then dividing by 4, we get 1/4. Negative. Any questions on that? So those are our critical numbers. They're where our increasing and decreasing change. I know this is a cubic graph. I know it starts out decreasing because it's negative. So it would go like this. I know that it turns twice because I have two critical numbers. So you could look at what the graph looks like without actually graphing it. So I know this is a minimum and this is a maximum. But we're going to go ahead and graph it. So you want to graph the one before the derivative. So it's this one. So we'll graph that on Desmos. So y equals -4/3 x cubed -21/2 x squared minus 5x plus 8. And there's our graph. If you click on one of the points, it will show you them. So that's on the axis. This one here is the axis. Notice there's another point right there, the negative quarter. So you do want to be careful of that. Notice it is a little larger than this one. So there's a relative max of 8.6 at -0.25. And a relative min of this one here, 62.8 at x equals -5. That's what I had showed here, a min and a max. Any questions on that? Oops. Let's try number 19. So we have x to the fourth minus 18x squared minus 4. And we want to find the critical numbers. So we take the derivative and we set it equal to 0. Four x cubed minus 36x, and this goes to 0. It's not quadratic, so we cannot use the quadratic formula. What could we do to solve this one? We can factor something out. What could we pull out? Difference of squares would work after, because right now it's not a square. But first we want to pull the x out and the 4. I would pull them both out. So we could factor a 4x out, so then we could use difference of squares. Remember, difference of squares is a squared minus b squared is a minus b and a plus b. So we have to get rid of this cube first. And if we pull out a 4x, it leaves x squared. And then pulling out 4x here, it leaves a minus 9. So they are difference of squares, x squared and 3 squared. So then it will factor further x minus 3 and x plus 3. The degree was 4. 4 minus 1 is 3. 1, 2, 3. We are going to get 3 critical numbers. For x equals 0, x minus 3 equals 0, and x plus 3 equals 0. Dividing by 4, we still have 0. Add the 3 and subtract it. 3 critical numbers. Any questions on that part? No, what you could have done instead of factoring this, but you need to be careful. This one still gets 0, dividing by 4. But you could use a square root method. Add the 9 over, and then take the square root of both sides. But what you have to remember, square root of 9 is 3. Notice I don't have the negative 3. So when you take the square root or any even root of both sides, you need the plus and the minus. So then it's 0 plus or minus 3. So then you have all 3. So you need to be careful of that when using this method. Factoring, you're not going to miss it. Any questions on that part? Okay. So we'll graph it. Look where the derivative is and go to the one above. Y equals x to the fourth minus 18x squared minus 4. And there's our graph. Notice the highs and lows, 1, 2, 3. This one here is the negative 3, 0, and 3. The y value, which is a min on these two, are the same value. So we have a relative min of negative 85 at x equals negative 3 and positive 3. The other one is a max, a relative max of -4 at x equals 0. Any questions on that? Positive. It's just, remember when you answer questions, I will give you up to 4 points on next week's exam. Just want to make sure I got everyone covered. Any questions on number 19? $27. Number 27. Any questions so far? So we have x squared minus 2x plus 1. Now when you look at this, let me write it first. I can't talk. To find the critical numbers, what rule do we need to use to take the derivative? Anyone? Yes, quotient rule. Remember, the quotient rule is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So you need to be able to take the derivatives quickly because you have to find all the other stuff. And in a 50-minute exam, well, I'll give you a whole hour, but in a 50-minute exam, you're not going to finish it if you're spending too much time on the derivative. So bottom times the derivative of the top, 2x minus 2, minus the top times the derivative of the bottom, which is just 1, all over the bottom squared. Any questions on that part? Okay. Because we need to set it equal to 0, it would probably be a good idea to simplify the top. I wouldn't multiply the bottom out though, because we're just going to get rid of it. But foiling the top, 2x squared minus 2x minus 6x plus 6. And then here I'm distributing a -1. So negative x squared plus 2x minus 1. All over the bottom squared. Combining like terms, 2x squared minus x squared is x squared. The 2x's cancel and leave a minus 6x. And then 6 minus 1 is 5. And this is a 2. Any questions so far? Okay, we will set this equal to 0. Now, remember we talked about the critical numbers are where it equals 0, but it's also values where it doesn't exist. Well, if we look at this for the domain, if x is 3, we will have 0. So we know that x minus 3 cannot equal 0, or x cannot equal 3. That's a critical number then. It is a point where you have to check. Sometimes it's not a relative max or min, and sometimes it is. In this case, it's probably not, because x cannot equal 3 here either. But there are cases where it can here, but it can't here, depending on your derivatives. So you do need to check it. Then we can get rid of the denominator. When you have a fraction, the only... Okay, the 2x squared didn't cancel. 2x squared minus x squared was 1x squared. I just marked it so I wouldn't look at it again. But the 2x's did. I just was marking it so I didn't keep looking at it. When you have a fraction, the only way it'll be 0 is if the numerator is 0, because we know the bottom can't be. So you could technically just set the top equal to 0. Or we can multiply both sides by x minus 3 squared. That way it cancels and just leaves x squared minus 6x plus 5 equal to 0. The top's equal to 0. So it's not that you're just setting the top equal to 0. You're multiplying the denominator to the other side, which when you multiply by 0, it just drops it out. Any questions on that? This one's factorable. Two numbers, when you multiply, you get a -5, and when you add, you get -6, are what? -1 and, yes, thank you. -1 and -5. So -5, -1. Setting them equal to 0 gives us two more critical numbers. So we have these two critical numbers and this one. These two are definitely a relative max or min. This one kind of depends on the function, but you need to check it. Any questions on that part? Let's graph it. Now, when you're trying to decide what to graph, look where your derivative is and use the one before. Most of the time it's the original, but not always. Delete this one. I equals, I'm going to put the numerator in parentheses, so then when I hit divided by, it will actually make a fraction bar. So x squared minus 2x, x squared minus plus 1. Divided by x minus 3. Here's our graph. Any questions on that part? It was 1, 5. Now 3. 3 is an asymptote that's going through here. If we look at x equals 3. It is a line, and it looks like it's touching it, but it's actually not. If I spread this out more, this is an asymptote, so it won't be a max or a min because it's getting close to it, but it's not going to touch it. So only 5 and 1 will give us a relative max or min. Sometimes it does exist and sometimes it doesn't on these ones, but this time it doesn't. And if we look at our graph, and this one is a min because it's coming down and then going back up. So there's a relative min of 8 at x equals 5. And then this one, that one? No. Wait, was it 1? Yeah, it was 1. So there's a relative max of 0 at x equals 1. Any questions on that? Positive. I want to show you one if we had endpoints. So if we had this warm-up one, f of x equals 2x cubed minus 3x squared minus 36x plus 4. And they told us the endpoints were, it was -5. Yeah, -5 to 10. So the first ones were just getting us used to it. We were using the whole thing. We didn't have any endpoints, but I want to show you one with endpoints. So first thing you want to do is we want to find any relative max and mins on the interval -5 to 10. First thing, find your critical numbers. Take the derivative, set it equal to 0. 6x squared minus 6x minus 36. Now this one's not too hard to factor, even though we see the 6 at the beginning. Notice we can divide it out. So we can divide all of these by 6. Now you can only do that when you have an equation, an equal sign. If you were just factoring, then you'd have to pull the 6 out. You couldn't just divide it. X squared minus x minus 6 equals 0. Any questions on that part? Right, so we need two numbers that when we multiply, we get -6. Then when we add, we get -1. Any ideas? -3 and 2. When I multiply, I get a -6. When I add, I get -1. So x minus 3 and x plus 2. Because we're multiplying, one of these has to be 0 then in order to get 0. So x minus 3 equals 0, or x plus 2 equals 0. Add the 3 over, subtract the 2. Any questions so far? Okay. Now, if our endpoint is -5 and 10, both of these are in that interval. So both of these are critical numbers. If it would have been -1 to 10, the square bracket means including the endpoints. And if it went -1 to 10, then this one wouldn't be included in your critical numbers. So anytime you're given endpoints and you're finding critical numbers, you only use the ones in the domain. So you want to be careful of that. Is there any questions on that? So in this instance, we would only have one critical number, 3. Here we would have both of them. Any questions? Positive. Okay. Let's try graphing it. Y equals 2x cubed minus 3x squared minus 36x plus 4. So here's our graph. Now, if you want to put the endpoints, you can. You can put -5 to 10. So -5 less than x less than 10. So it's showing us from -5 to 10, but it's not showing us our low point. Is it -2? Oh, it cut off a lot. I don't know why it did that. I'm going to go over here and put it in. So x is from -5 to 10. Now I have this one, so this is good, but I'm going to change this one. No, that one's good. It's this one to -80. I think that'll get it. That way then I can see my low and my high all at once. You can also zoom in and out. If you click on your graph, here was my one critical number, -2. Here's my other critical number, 3. Now when we're using -5 to 10, this is included in it. But if we're going from -1, then this one wouldn't be included. Any questions on that? So you have to be careful of your intervals when they're given. Any questions on that? So that's the basis of the next 2 sections we're going to learn. We'll finish 8.2 next class. The rest of it's story problems. And then there's like 5 other problems in chapter 9. Excuse me. Any questions?